If you wish to make an apple pie from scratch, you must first invent the universe. These are words of Carl Sagan. It means you start at nothing. I'm not asserting that the universe started ex nihilo from nothing, but you get my point. If you ask a child to start counting, he is likely to say 1, 2, 3, 4, and so on. It is intuitive for us to start at number 1. Even in the alphabet, this concept that something has to be first is mirrored with the letter A. It is also called alpha, and alpha is something that comes first. It is very intuitive for us that counting starts at number 1. I do not know what was the first ever use of numbers for human civilization, but I don't think it is outrageous for me to assume that the first use for numbers was counting. We needed to count objects, items, oranges, apples. I want you to notice that I don't need to count the number of objects in an empty box. You simply don't count something that doesn't even exist. You can kind of see why the number 0 was only later introduced into the number system. We didn't feel the need to count something that isn't even there. In fact, even the Greeks, who did a great service in creating and developing math, failed to introduce a number that represents nothingness. The figure or number 0 is thought to have originated in many different societies. We know that the Indians and the Mayans were one of the first recorded civilizations that introduced the number 0 in their numerals. But what I want to tell you is inventing a number and introduce it into the number system, it is not a simple matter. I mean, why don't we just invent a number right now, as I'm speaking? The number 0 represents nothingness. Why don't we find any figure and assign a concept to it and just invent a number right now? You see, what I'm trying to point out is inventing a number is really not a simple matter. You don't just introduce a number, invent it, and then the next day you're doing math with it. We have endless and really deep debates about non-existence itself, let alone do math with a number that represents it. Because when you introduce the number, this is actually the easy part. You've still got all your work ahead of you. If you're going to use it in math, you're going to have to come up with rules to make it coherent and logical with the rest of the math. That means, how does it actually work? How are you going to use the number that you have just pressed into the numbering system? The number 0 that you see today was used just like a comma in language to separate between numbers. It was used to distinguish between this number and this number right here. This would be 95 and this one is 9.5. So this is analogous to introducing a comma in language. We know how important this is because listen to those two sentences. I'm sorry, I love you. And the other one is, I'm sorry, I love you. See, the difference between them is just the comma, but one of them expresses apology followed by compassion, and the other one, pity for the fact that you have compassion. They are vastly different, and the difference between them is just the simple comma. You can see how important it is to express differences between tiniest matter when it comes to text. It is also true for numbers, and that is why 0 was invented and used in that type of service at first. It wasn't really a number, it was just a separator. But then the Indian mathematician Brahmagupta, and I've probably absolutely butchered his name, anyone who speaks Indian can let me know in the comments, he used the number 0 as a number. And then later Fibonacci, in his book of counting, decided that it is a good idea to put it in the numbering system and actually start with it in the series 0, 1, 2, 3, 4, etc. when counting. Now, like I said earlier, how does it work? How do we introduce it into the math? Remember something here. Math is a universal language. That means it has to work the same way everywhere on the globe. So if in one country they use 0 a certain way, you can't have the math that is used here be different when you go to a different country. It has to be universal, so we have to agree on the way 0 is being used. And that has not been easy. You see, addition and subtraction is not contentious. It is simple even when using 0. Multiplication is also a little bit easier, but when it comes to division, now that is a dangerous game to play with 0. I want to show you something kind of crazy and cool. Take a look at this simple example. 28 over 7 is 4. You could also write this line like this. Now I can cross multiply and just get this expression right here. Now let's play the dangerous game I told you about with 0. Let's say 0 divided by 7 is equal to some random value, and we're going to call it a. Just like from before, I can cross multiply, like the example I just gave you here. Now this gives us that a equals to 0. Okay. Now let's reverse this. Let's say 7 divided by 0 equals to some random value b. Cross multiplying, you will end up with the insane idea that 7 equals to 0. We escape this by saying dividing by 0 is undefined in math. It actually makes sense that it shouldn't happen because it's really not logical. Let's think about it intuitively. If I give you 5 pence and I tell you to distribute it between 5 people, you're going to give each person a pen. But if I give you the 5 pence and I tell you distribute them on what? You cannot divide something over nothing. You're just gonna end up with it. So the question isn't even complete. It doesn't make sense in math. It's not logical, and math has to be logical. The void, non-existence, is a mind-blowing concept in real life, but also in math. Nothing is quite something. I've been dying to say that. I'm finished.